Okie dokie, today I'm talking about a repressible operon. I'm going to go over the basics, looking at the parts on the top, very similar to the inducible operon, regulatory gene, promoter region operator, the gene piece is itself, and the terminator, so the end piece. And a repressible is just different from inducible in the fact that it's usually on, let's see, usually on, and you turn it off. Whereas in the inducible one, it's usually off and we turn it on. And we're going to see this when I get into kind of how it works. So I'm going to think this is turn off, or repress, almost stop. So we have our regulatory gene, and it's going to code for our repressor protein. But this repressor protein is different. It's called an inactive repressor protein. And this is because you're going to need the inducer molecule, which is going to be called the co-repressor molecule, to make a conformational change to it. So I'm going to draw the same circle, kind of. And when we have that bind to it, so when we have this come in, then we will get that conformational change in the protein, and then it's going to be able to bind to the operator. And so then once we have it on the operator, I know these are crude drawings, but we have our RNA polymerase here, RNA poly, and usually without this repressor protein here, then it would be copying, and you'd be making the genes. So I'm just going to put like enzyme A. And it's copying and copying and copying. Well, once we have enough enzyme A, it happens to be a circle, then it will bind to this inactive repressor molecule, changing the shape, and then causing it to stop. So kind of once we have enough of this, then we're going to stop making it. And that's kind of the idea behind a repressor operon. It's on and on and on and on and on, and then what it makes is going to bind to an inactive repressor protein to bind to the operator to physically block RNA polymerase from making any more of that thing. And that's a repressible operon. I hope that was helpful.